So 5.2 kind of builds on yesterday. Yesterday we were looking at ratios. And yesterday, I wouldn't write this down, but yesterday we looked at ratios. You could say it's like a 4:3 ratio. Or sometimes they'd write it out like 4:2:3. Or often it'd be a fraction like 4:3 that way, 4/3. This section we're pretty much just switching to this last way, just to fractions. We're going to look at ratios as fractions. Good? So equal ratios are going to be two of these things. So it could be any of them, but typically we're doing fractions, like I said. Two of these fractions that are equal. So two ratios that have, maybe we'll say the same value. So if I were to do 4 divided by 3, I get 1.3 repeating. So we're saying, well, what's another fraction that equals 4/3 or equals 1.3 repeating? So anybody in their head, what's another fraction equal to 4/3? So Katie said 8/6. And one way to get that is to say, well, you could get from 4 to 8 by multiplying by 2. So this is kind of like multiplying by 2. Well, then you have to do the same thing to the denominator so that it's still equal. Essentially what we just did, and I don't know if I'd write this, but we did 4/3 times 2/2. Well, 2/2 just equals what? 1. So essentially we took that 2/2 and we just said, what's 4/3 times 1? So we changed the numbers, but it still has that same value of 4/3 when you multiply by 2/2. You could have instead multiplied by, instead of 2/2, you could multiply by 3/3, 4/4, 8.2 over 8.2. You just need to multiply by something over itself. Could we divide also?
Yeah.
Yep. So multiply or divide by a certain thing. Okay, so if I go down here, we okay on the first example?
Yes.
Okay. So remember the ratio tables from last year?
Yes.
So essentially, what we're trying to say is this here is our first fraction. Our first fraction is this 9/12. So we're really just trying to take these fractions for ratios and put them into like a data table. Well, if we do that we were doing before, how could I get from a 9 to 18? I could
Times 3.
times 2. So if I multiply my 9 by 2, I need to multiply my 12 by 2.
24.
Yep, so it'll be 18/24. You could go from 24 to 48 by times 2. So times 2. Nate's right, I get a 36. So I did my 18 times 2 to get the 36. We still good? Now, sometimes it's a little bit tough to go from like a 48 to a 2. Say that's dividing by 24. But what's 36 divided by 24? You could get your calculator, not a ton of fun. If instead we were to do this, how could you get from 12 to 2? You could divide by 6. What's 9 divided by 6? Anybody do that in their head? 1.5. Nice. So the point I was trying to make is if it's not real easy to go like from this to this to this to this, you could, if once you have one of these, you could go from this to any of the others. So that you can go from any column, any ratio to any other one. Fair enough? So if we're going from 9 to 3, we could divide by 3. So 12 divided by 3? 4. Yep. We okay for those? Those are like guaranteed test quiz question. It seems like people kind of struggle with them from year to year, so if it's confusing, either say something now or when you're working on homework, get one like that and quick call me over. If we were to do this next one, 2 over what? Or maybe what's an easy one to go to?
1.
Sure, we could do the 10. So what's going to go right here under my 10?
60.
Yep, 60. Nice. So probably did like times 2 and then times 2. So we get a 60. Above the 120, we're going to have a 20. Nice, because it's another times 2, right? Times 2, and then a times 2. Well, how do you want to get to the 2? From the 5, the 10, or the 20? I heard the 10 first, so 10 divided by
5.
5 is 2, so 60 divided by 5 is
15.
I think 12, right? Should be 12. And then last but not least, our last square is
1.
6. Because we could do the divided by 2 here. So divide by 2, divide by 2. Another way that you could get some of these would be to work vertically. There is nothing wrong with that. I'm just going to erase a little bit in here, kind of some of my chicken scratchings down there. But say what do you do to 30 to change it into a 5? Divide by 6, right? So you could go from 120 to the number above it by dividing by 6 and getting the 20. Or you could do it the other direction, say 5 times 6 gets me 30. So then 2 times 6 gets me 12. So you have options for how to go about doing it. Okay to move on? Awesome. Before I flip the page, you can turn yours if you want, but before I flip it, I want to make one point here. That this here is a whole bunch of ratios. That this really is supposed to be 2 over 12. This one here is 10 over 60. And those are supposed to be equal now, right? Or we have this here, you could say is 20 over 120, and that should equal both of the other two. So the next thing should be proportions in our notes. Proportions are just going to be something like this here. It's one ratio equals another ratio. So I'll turn the page. So proportions, say 2 ratios are equal. So example 4, if I want a proportion, I have 1/3. That's going to equal something over something.
2/6.
2/6, I like that. So you guys went and multiplied the 1 by 2, multiplied the 3 by 2. We now have 2 ratios that are equal, or we have one proportion. Okay on that? Good. Okay. So if you get something you're not sure if it's a proportion, so often they'll write it kind of like this here. We have 3/4, we have 15 over 20. Are these two equal or not? So there's a couple ways you could do that. One way is going to say, well, I heard a times 5. So I'm guessing Taylor's saying, well, times 5, are they equal? Yep, because 3 times 5 is 15, 4 times 5 is 20. That's what I mean by this check like in Roman numeral 1, is just to go and see what would that second ratio be if you were to go and do the math. The other way is if we had something like this. Do you guys remember doing, I wouldn't write this, but 3 over 4 equals x over 20? And we would cross, multiply, and divide. So we'd say 4 times x equals 3 times 20. And then we divide both sides by 4 to find what x is. So that cross multiplying works, that this times this equals this times this, if we know the two fractions are equal. So if we wanted to check and see if these are equal, we could say, well, 3 times 20, does that equal the 4 times 15? Well, 4 times 15 is 60. 3 times 20 is 60, so they're equal. So that's a different way to check it. So going up to number 2 right here, you could test and see if it's a proportion, or by that we mean if they're equal, by either check like you did in Roman numeral 1, or if they're equal, the cross products. Products means multiplication, cross means we're kind of going that diagonal thing. The cross products will be equal. How you do it, I don't think I'm going to ask you to do it a certain way to get credit. So how you do it is really up to you. For me, I like doing that first way. I like saying, okay, 3 times 5 and 4 times 5. I prefer that way. But sometimes the numbers are just nasty. To figure out what you're going to have to multiply to get from the first to the second is not a nice number. It's going to be 8.24 or something. In which case, it's easier to do the cross products. But it's totally up to you. The second one, how do you want to check it? Is it equal, not equal? I'm going to do the first way, times 5, and it's not equal because?
9 times 5 work.
Exactly. That 9 times 5, this we're told should be 45 if it was equal, or you'd have to change the top number. So this one here is not equal. Or you could say that example 6 is not a proportion. Questions before we hit Roman numeral 3? And Roman numeral 3, looking at what's a better deal. Often you get a bigger box of cereal. So I've Raisin Bran Crunch. We eat a lot of Raisin Bran Crunch in my house. So say it's $3.45 for an 18.2 ounce box. It's $3.99 for a 24.8 ounce box. Usually the bigger boxes are cheaper, but is it in this case? We could take and make it into a ratio. A lot of times people, they just take the two numbers in the problem, so they take these two numbers and divide them. Then they take these two numbers and divide them without really knowing what's going on. I would encourage you to either write out the units or at least be really careful. But if I were to do the first number divided by the second number, so the cost here divided by this here, is the better deal going to have a bigger answer or a smaller answer? Do you want more dollars per ounce or less dollars per ounce? Less. So if you do it this way, then small is better. Small equals better. But it's totally legitimate to do the reciprocal of that and do the amount of ounces, the 18.2 divided by the cost, which would give you ounces per dollar. What's the better deal in ounces per dollar? Is it still the smaller number? No, you want more ounces per dollar. You want a bigger number of ounces for every dollar. So this one, the bigger one of the two is better. So I would just encourage you when you figure out how you want to combine the numbers, kind of have in your head, are you looking for the higher number or the lower number? Because that, I think, is what messed up most people last year. So we have two options. What do you want to do? Top way, bottom way?
Bottom.
I heard bottom, so we'll do this one here. So we're going to do the ounces per dollar. So if I take my first part there, so I'm going to say it's 18.2 ounces over 3.45. Now I'm going to have to grab a calculator and plug that in, because I did it the other way in my notes. So if I have 18.2 divided by 3.45, and I get 5.28 with a little bit of rounding. So 5.28, and that would be the number of ounces per dollar. And now if I take my second one, so I'm going to take the larger box, and if I do the same thing, I have 24.8 ounces divided by 3.99. So 24.8 divided by 3.99. And now I get 6.22 ounces per dollar. So what's the better deal?
Bigger.
Yep, the bigger box. So better deal. As you'd probably expect, because the bigger box gives you more ounces per dollar. If you'd done it the other way, if you'd gone with this top way, we would have came up with, you turn the page in my notes, would have came up with 19 cents per ounce for the first one and 16 cents per ounce for the second with a little bit of rounding. So the second one would have been a better deal because it was only 16 cents per ounce rather than 19 cents per ounce. Very last thing. I know for me, I'm kind of a sucker for a good deal. So I'll come and be like, Raisin Bran Crunch is on sale at Meijer's. And I'll come home with like 8 boxes, maybe, hypothetically. Okay, so if they were to give the small box on sale for this, do you buy a bunch? I'm going to go and do it the same way as what we did up here. I'm going to do the ounces per dollar and see how does it compare. So the ounces, the smaller box was 18.2 ounces. I'm grabbing that number from up here. And now it's 293. So if I grab my calculator, do 18.2 divided by $2.93, I come up with a 6.21. So 6.21 ounces per dollar. So is it a better deal?
No.
Barely. Ooh.
Yes.
No. It's a worse deal. It's barely worse because we said this way the bigger's better. I kind of fell for my own trap. Bigger's better. So this year I'm getting 0.01 ounces less for every dollar. So you actually still be better off getting the bigger box. But as I so cleverly demonstrated, it's important to know, are you looking for the bigger answer or the smaller answer? Because it's easy to make a mistake like I just did. So let me know if you have questions.